Hi everyone, let's start Unit 2 today. So permutations and combinations, Lesson 1, the fundamental counting principle. This unit, the entire unit, is the same in the Math 30-1 curriculum and in here. All right, so you are learning the same thing. And this is an interesting unit because it takes a lot of logical thinking, logical reasoning, just similar to Unit 1, but then now there's apply more math to it. You need to do some calculation and adding and subtraction. The main thing for this unit is to understand, like to be able to use the concept, understand it, and apply it. The math itself is not too complicated, not a lot of algebra. It's simply just adding or multiplying. But then it's the concept, it's the application that is the part that you need to pay attention to. All right, now let's look at what is the fundamental counting principle. What is this whole unit is about? Basically, this unit is about find out how many ways, we call them permutation or combination, how many ways you can arrange certain things. All right. And then the fundamental counting principle is instead of asking you to like count each combination, as in first example, you see we have a quick way to do it. So Lucy is shopping for a sports utility vehicle, SUV. The dealer say he has 3 different models and each one has 5 different colors. So the question is how many different model cars are there? All right. So the 4 models are Cross 4, X Grand, what else? Let's make it smaller. And Trail Pro. Okay, so those are the SUV. Each one come with 5 color. So how many different model, different color are there, right? Well, you can look at this tree diagram. This is how one way you can think about it. You have 3 model here, and each model have 5 different color. So you can write the answer here. So if we continue, so this will be white, this will be black, and then you will have the Trail Pro, right, in silver, Trail Pro in white, Trail Pro in black. So I'm just saving space, saving time. All right, how many choices are there? Well, 3 kinds, each one have 5, so 3 times 5, that's 15. You can also like just look at the outcome here. Okay, so this is called a tree diagram. So this where you start is called the root, all right? And then you have some branches in between. And then at the end, you have some leaves. It's the end result. All right. So it's just a way to organize the information. In here, the leaves are the different kinds of outcome, the different kinds of choices available. You count them, and then you get it's 15. All right. So they just want you to ask the 3 model, 5 color of choice of choices for color. How many different ways? Like how did you arrive the answer 15? If you look at 3 and 5, how do you get 15? The answer is, hey, multiply them. So basically, that's the fundamental counting principle. When you want to count how many different choices, how many different options, how many variations are there, you just look at the number. Do you need to physically like draw a tree diagram every time? You don't need to. You multiply the number. So the fundamental counting principle asks you, when you want to count the numbers, you multiply the choices there. Then you get the answer. So now, extending on this, so for each SUV, you can also come with 2 addition. You can also have the standard addition or the leather addition. All right. So like in a hot summer day, you don't want to sit on a leather seat. It's very hot. Okay. So if I have 15 choices and each one can be a standard or a leather, so how many ways, how many choices are there? It says use a tree diagram. So for each one, you branch off again for a standard or like a leather, right? And you do that for all the 15 choices there. Each 15 choices split into 2. So what will be your answer? 3 times 5 is my original choices, number of choices. Now each one have 2 options. So what do you do with the 2? You multiply them. Then you get 30. All right. So the whole unit is about this, right? It's building on fundamental counting principle, and then we'll see like more varieties of question, and then you need to think and you need to like apply but the whole thing, the core of it is like this: counting difference of ways. And this is a common unit in Math 30-1 and 30-2. Okay, so he says here, he summarizes it here for you. You just look at the way they put it is they make it general, more general. You have a task which have several stages. The task here is you choosing a car. First you choose the model, next you choose the color, next you choose the addition. Right? That's your task divided into different stages. And then for each stage, how many choices are there? So the first stage have A number of choices, second stage have B number of choices, third stage has C, and then the fundamental counting principles say, what do you do with this number? You multiply them. Okay, so let's try the following. Example number 1, a toy manufacturer make a wooden toy in 3 parts. The top part is color red or blue, the second part orange or green, orange or white or black, the last one is yellow or green. How many different color toys can be produced? Okay, let's use a tree diagram. So I make it really small. Okay, it doesn't have to be really small. So first you have red and blue, that's your first stage. My second stage could be orange, white or black, orange, white or black, no matter what is the first one is. Now, for the bottom, you can have 2 choices each. So just branches off. All right. Look at how many leaves I'm making. You can either have yellow or green, yellow or green, yellow or green, yellow or green. Okay, the writing is not like because the computer didn't take writing very well. Okay, it's not my problem. Okay, so the question is how many leaves are there? Then you count 1, 2, 3, 4, 5, 6, 7, 8, 12. Okay, there are 12 ways. How about we use fundamental counting principle? This process, this task can be break down into 3 stages. The first stage, you first choose the top part, either red or blue, 2 choices. The next part, orange, white, or black, 3 choices. The third stage have 2 choices. What do you do with this number? Multiply them, you get 12. That's your answer. Oh, okay, I hope you like this unit. All right, so consider them as part 1. You need to make a toy that consists of part 1 and part 2 and part 3. Now, what are we emphasizing here? We are emphasizing and. When you make a toy, it has part A and part B and part C, right? 3. You won't say part A or part B or part C. So it's either and or. So in here, the logic is this toy, you produce part A and then part B and then part C, or 1, 2, 3. So when you say and, you will multiply, okay? In this example, when you say and, you will multiply the numbers. What happened when we see or? Well, we'll see it when we come in soon. All right. Example number 2. A math quiz consists of 6 multiple choice questions. Each question has 4 choices. How many different sets of answers are possible? Now, there are 6 multiple choice questions. So the way to understand it is don't use 6 times 4. Wrong thinking, right? So you have 6 multiple choice questions. 1, 2, 3, 4, 5, 6. When you do a test, you do it one at a time, so you are doing it in 6 stages. Each stage have how many choices? 4 choices. Then what are you supposed to do with this number? You're doing question 1 and question 2 and question 3 and question 4 and so forth. No test asks you to just pick one question. You do all 6, so it's n. What do? You multiply them all together. So n is 4 to the power of 6, and whatever answer you will get. And you find out the number is quite huge. Therefore, a multiple choice question is a valid form of testing because if someone just purely guessing, close their eye, just punch in some numbers, the chances of getting 100 is 100%, all right, is 1 over 4,096. Just 6 questions, you have 4,000 different ways of answering it. You can have A, you can have A, B, you can have A, B, C, D, right? So on. There are total 4,000 ways. It's quite amazing. Just a small test, there are 4,000 ways to answer it. So if someone get 100%, it's quite likely they know what they're doing. They're not guessing. Otherwise, the chance will be 1 out of 4,096 to get it all correct. All right. Now let's do something more interesting. So far everything is too easy, can't be true. Let's look at this. Involve restriction. What if you have some restriction, you have some condition on your selection? Let's see. Now, to solve problem with restriction, it is important to deal with the restriction first. What does that mean? Let's read the following question. Eric has assigned task of determining how many odd 4-digit numbers are there. Okay, your task is to find out in this whole world how many 4-digit odd numbers are there. Now, this is a 4-digit odd number. What makes it an odd number? Anything end with a odd number, the unit digit, if it's an odd number, then the whole number is an odd number. When you have a 4-digit number, it cannot start with 0, right? Like 0267 is actually a 3-digit number. So we only want a real 4-digit number. So the first step is look at the restriction. What are the restrictions? When you pick the 4-digit, that is your task. You want to pick 4 digits, okay? So picking this 4-digit, you have some restriction here. What is the restriction? The first restriction is the last number need to be an odd number, right? In order for the whole thing to be an odd number. So a 4-digit number is an odd number if the last digit is odd. Now, how many digits are there? Well, there are 10 digits from 0 to 9. How many of them are odd? 1, 3, 5, 7, 9. 5 of them are odd. So you write the number 5 there, not represent the actual digit 5. It represents the number of ways, number of different digits you can choose for this last place. You can choose 5 of them. Now, how about another restriction? The restriction is the first digit cannot be 0, isn't it? Right? If it's a 0, that's not a number. So out of all the 10 digits, you can only choose 9 of them, 1 to 9, to put in the first place. So the first one cannot be 0. So then the question is now turn into how many ways to find out all the 4-digit number. Okay, so give me a minute. There's something wrong here. Okay, so the question is, there's some problem with the pen, so I need to use my mouse. So my handwriting will be even more interesting. Okay, there are 9 ways to choose the first digit because there's a restriction here. The restriction is it cannot be 0. Now, are there any restriction for the 2 middle digit? No, there's no restriction. So they can be any of the 10. So you put a 10 there, and you put a 10 there. Now, what do you do with this number? The fundamental counting principle tell you to multiply them. So 9 times 10 times 10 times 5, the answer will be 4500. So there are total 4,500 odd 4-digit numbers there. Okay. So this will be interesting, right? That's an interesting question. Let's try B. Eric has now assigned the task of determining how many odd 4-digit numbers are there which have no repeating digits. Okay, what does that mean? Which means if the digit has been used, you cannot use it again. So this task of picking a 4-digit number, I can wrote it as 4 stages. All right. And now there's restriction. Okay, well, let's start with the restriction. The first digit cannot be odd, right? The last digit cannot be odd. All right, so have to be odd. So there's 5 digit there. You always start with the one with restriction. The first one cannot be 0, so it will be 9. But then we have one more restriction. Okay, what's the restriction? Okay, well, let's try something. Okay, explain why the first step is still valid, but the second step is not. Okay, that's the thinking. Okay, if the first one is odd, right? First step, we put 5, the last digit is odd. However, the first digit cannot be 0. Can I just put a 9 there? No, because now you need to, you cannot repeat the last digit. So how about putting 8? Would that work? Would that work? I'll put in 8. Okay, well, that will work. Put in 8. The reason is it cannot be any of the odd digit number appear there, and it cannot be 0, right? And 0 is not an odd digit number, so you cannot have odd digit number, you cannot have 0. You cannot have this odd digit number that you choose for the last one. So you have 1 down and it can be 0. That's why it's 8. Well, how about the next two? Well, it cannot, there's no restriction. It should be 10, 10. However, it cannot be this digit, cannot be the last digit. So it's only 8 choices left instead of 10. Then how about the last one? It cannot be this 3 digit that appear. So that's why it's 7 choices. Okay, so number I written is the choices. So now you multiply them. This